All right, exponential word problems. Let's get on to it. You drink your morning beverage with 120 milligrams of caffeine. Every hour, your body filters out 12% of the caffeine. Okay, so let's think about this logically. So you drink your, you know, coffee or tea or whatever. Either way, your drink has 120 milligrams of caffeine in it. Every hour you lose the caffeine in your system. So is this going to be a word problem of exponential growth or exponential decay? It's going to be a word problem with exponential decay. So in particular, let's pay attention to our f of x and our x. Remember, our f of x depends on x. So let's pay attention to the amounts that the two variables represent. So I see the amount of caffeine in my body and the amount of time that has passed. So the amount of caffeine depends on how long it's been since I've drank it. So the number of hours since I guzzled it down for energy. All right, so if I know that the caffeine depends on the number of hours, now let's put the words into the equation. So remember that f of x is equal to the original amount times a scale factor to the x power. So how much caffeine did I intake? How much caffeine did I drink in my first? Sorry, I'm stumbling over my words. How much caffeine originally? 120 milligrams. Now, I'm going to lose 12% of the caffeine every hour. So think about this as a coupon. If it's 12% off, how much of the original as a percentage do you pay? How much remains? Well, 100% minus 12% is 88%. So 120 times 0.88 to the x power is going to be my equation that reflects this data. So the amount of caffeine depends on how many hours it's been. So f of x is equal to 120 times 0.88 to the x power. So let's get on to it. How much caffeine is in your system after 2 hours? How much caffeine is in your system after 8 hours? So let's answer this one first. So what information am I getting from this question? How much caffeine means f of x is unknown. So we solve for f of x if we know x. If we know that x is 2 hours, that will tell us how much caffeine is left in our system. So let's plug it in. So remember that f of x is 120 times 0.88 to the x power, where we know that the x value is 2. So let me get my calculator. So we need to figure out 120. Come on, you, turn on. There you go. 120 times 0.88 to the second power. I'm just going to round to the nearest 3. Yeah, there we go. That's good enough. So if after 2 hours have passed, then there's only 92.928 milligrams left of caffeine. 92.928 milligrams remaining after 2 hours. Now, after 8 hours, I know that all I need to do is plug in x equals 8 into our exponential function. So 120 times 0.88 to the x power, where x is equal to 8. So I picked 8 hours. The book said 2 hours, but I like 8 hours because an 8-hour shift is typically your workday. So let's say you only have 120 milligrams of caffeine, and that's supposed to last you 8 hours. How much caffeine is left in your system? So what you do is you would do 120 times 0.88 to the 8th power, and exponentially decaying, that would be only 43.156 milligrams. So after an 8-hour workday, there are still 43.156 milligrams of caffeine left in my system. Okay. Now, number 4, how long until you only have 12 milligrams in your body? So I just want to put a little sidebar over here. So I know what you're thinking. Why didn't you put a problem where it's how long until you only have 0 milligrams in your body? Well, here's the paradox of math. It turns out mathematically that's not possible to do the log of 0, because what you're trying to do is, and we'll discuss that in the unit after this actually, this thing called domain. 10 to what power is 0? Exactly, that's impossible. So I just picked a number really, really close to 0, but easy to make into a fraction, so I went with 12. So anyway, 12 milligrams, that tells me the amount of caffeine. So that tells me f of x, sorry, let me get that on top of the book. F of x is equal to 12 solve for x. How long? Exactly, I don't know the number of hours. So I'm going to set the equation itself, 120 times 0.88 to the x power is equal to 12 itself. Now, let's solve for x. I'm going to divide both sides of the equation by 120. So that cancels out, leaving me with 0.88 to the x power is equal to 12 divided by 120. That is 1/10, or I prefer 0.1. Okay, so now what can I do to get that x easy to solve? What have we been doing this whole time? Let's apply log to both sides of the equation. Because what's the most important rule? The power factor rule. So now that I've got 0.88 to the x power and apply log to both sides, that x flies to the front. Now I've got x log of 0.88 is equal to the log of 0.1. And now let's solve for x by dividing both sides of the equation by log of 0.88. Cancel out log of 0.88 on both sides. If I divide both sides, I'm going to get my calculator now. Clear, clear, clear. Log of 0.1 divided by log of 0.88, and that gets me 18.012. And remember, x is the number of hours. So how long does it take for me to get all the caffeine to wear out of my system? About 18 hours. Okay. It takes about 18 hours to basically get rid of all the caffeine in your system if you've taken 120 milligrams of caffeine. Okay. Let's go on to the second word problem. So you buy a new computer for $2,000. Every year, it loses 30% of its resale value. Declare your variables. Write an exponential equation that reflects this data. So remember, f of x depends on x. Always remember that. Your y depends on x. So what, in an English sentence, what am I comparing? How much the computer is worth depends on how many years it's been since you purchased it. So the value of the computer measured in dollars depends on the number of years since you purchased it. Now, when you take a computer and it loses its resale value, is that an example of exponential growth or exponential decay? Decay. So remember that f of x is equal to the original amount, which is $2,000, and it's going to lose 30% of its value. So if you had a coupon that was 30% off, what percentage of the original price do you pay? 70%. So 100% minus 30% is 70%, or you can write this as 0.7. You can write this as 0.7 to the x power, but I'm not going to get mad if you write this as 0.70. In fact, I like to write it as 0.70. So if you want to leave it like this, be my guess. I like 2 digits because it makes me think a little bit clearer about this, even though it's kind of unnecessary. Okay, so let's answer the question. How much is the computer worth after 3 years? So what information does this tell me? Well, what is the computer worth? Hey, in fact, what is the computer worth? It's like the question is asking, I don't know what f of x is. Solve for f of x. After 3 years. Oh, years. X is equal to 3. So x is equal to 3, solve for f of x. The strategy is in the question. So once I've got the equation, I'm in business. So we're going to do f of 3 if the equation is 2,000 times 0.70 to the x power. So in this case, f of 3 means plug in x equals 3 into this equation. I'm going to get my calculator. 2,000 times 0.7 to the third power. 600. Ooh, perfect. No dollars at all. Okay, I mean, no cents at all. $686. Wow. On the money. Okay. Then, question number 4 is, well, when will the computer be worth only $100? So, when will the computer? Well, that when is a question of time, so that tells me I don't know the years. And be worth $100? Well, the value of the computer is given to us. F of x is equal to 100. Solve for x. The strategy is usually in the question. So now we're going to set the equation itself. What is it? 2,000 times 0.7 to the x power is equal to 100. Okay. And now we're going to solve for x. So what I'm going to do is I'm going to divide both sides of the equation by 2,000. You get a calculator. 1, 2. So 0.70 to the x power. I mean, I could do this by hand and just go, okay, cancel. 1/20th. I could do 1/20th or the decimal equivalent. Either way, I did a decimal last time, so I'm going to do 1/20th now. All right, so 0.70 to the x power is equal to 1/20th. Well, what can I do? Well, I can log both sides. I need to solve for that exponent, so I'm going to take advantage of the power factor rule. So log of 0.70 to the x power is equal to log of 1/20th. And I'm going to factor that exponent to the front, leaving me with x log of 0.70 is equal to log of 1/20th And now to solve for x, I'm going to divide both sides by log of 0.7. So now, this is where the calculator comes into play. Here we go. Cancel out, and now I've got x. So that's going to be log of 1/20 divided by the log of 0.7. 8.399. So how long does it take for the computer to be worth $100? About 8.399 years. Okay, now I want to end it on a fun one because I'm sure this is what's going to hook you. So every once in a while I get, for some reason logarithms are are like the punching bag of like upper division math, because in ninth grade you typically reach the peak of like, when do I do math on an everyday basis? Like, for instance, like, you could say the total bill is equal to $3 for a case of soda, or $4 for a case of soda, and you can do y equals 4x, where x is the number of cases of soda. You get the idea. Is that grocery store math typically ends around algebra 1. And then algebra 2 comes, and people are like, they start getting mad at, math teachers like me, and they go, hey, how come you guys are doing like quadratic formula and radical functions and logarithms? I'm like, I don't know I've never done a logarithm. Well, okay, here's the real life application for a logarithm. So suppose you get hired for your first full-time job, and let's just say you make $50,000. Now, I don't know if you know this, but legally, you have to be able to make somewhat of a raise every single year. I just pulled this number out of a hat. Sometimes it's a decimal. Like I've interacted with places where the annual raise is 2.7%. Some places it's 3%. Some places it's 4.5%, 4.25%, 3.7. You get the idea. So I just said 4%. I just pulled a number out of a hat. So suppose you get hired for your first job at $50,000 a year. And every year you increase your salary by 4%. So let's get the variables out of the way and let's have fun with this. So your salary depends on how many years it's been since you've worked there. Your salary is measured in dollars, and X is the number of years you have worked there. Okay? So obviously, you want your salary to be a function of exponential growth. Not, you've been here 20 years, let's just hack your salary. No, you want your salary to grow. So $50,000, poor Earl. Earl's been working there 40 years. He's making 30 cents a year. So 4% growth. What is the scale factor if it's 4% growth? 1.04 to the x power. So that's your equation, $50,000 times 1.04 to the x power. So now that we've gotten this out of the way, I figured it'd be much easier to look at this from a table. It actually looks kind of cool. So let's suppose that your formula is 50,000 times 1.04 to the x power. Okay? So why did I start off with x equals 0? Well, remember that year 0 is literally your starting year. It's your initial amount. So if I were to just draw this little table and say 50,000 times 1.04 to the 0 power, well, remember that anything to the 0 power is 1, including, let me just put this right here, 1.04 to the 0 power is just 1. So 50,000 times 1.04 to the 0 power is 50,000 times 1, or $50,000. Okay. Well, what if I do 50,000 with a 4% annual growth? And I'm just going to get a little ahead. Just going to do this. So you just want to fast forward for 30 seconds or so, however long it takes. Hopefully I'm a little bit quicker than that. Okay. So suppose you want to figure out what a 4% annual increase is from your starting salary. So if you want to do 50,000 times 1.04, your next year's salary will be $52,000. So right off the bat, you see a $2,000 increase. But is the following year going to be a $2,000 increase? Let's find out. So let's do 50,000 times 1.04 to the second power. 54,080. So $54,000.80 if you've worked there for 2 years. Okay. Let's see if we work there for 3 years, 4 years, 5 years. So 50,000 times 1.04 to the third power. Yes, it is true. You will get cents sometimes for your salary because it has to reflect the contract. You have a 4% annual interest. So $56,243.20. Well, let's make that grow by another 1.04. So that's 58,492. 0.928. So let's go with 93 cents. Let's round that to the nearest cents. That'd be 93 cents. Okay, but you get the idea. Let's just do this one more time. Times 1.04. 60,832. 0.65 cents. Yeah. So let me just clarify this really quick. You are calculating a 4% annual interest on the year before. So obviously the jump from 50,000 to 52,000, that's a $2,000 jump. But it's not a $2,000 jump, it's a $2,080 jump into the next year. And then more than a little bit more than 2,000 over here. You get the idea that that 4% annual interest is significant as your years progress. So just to give you an idea of what awaits you in adult life is to look at that percentage of growth. Now let's get on with the 2 questions at the end. So I can't wait any longer. I'm not going to do this table forever and ever. How long does it take if you start out with a $50,000 salary and you have a 4% annual increase? How long does it take to get to $75,000? How long does it take to get to $100,000? Yeah, I want my salary to double. So let's answer this appropriately. Because if this is the case, you want to set f of x equal to $75,000 and solve for x. So what this means is you have well, I mean, I could do it that way, but $50,000. And the formula is times 1.04 to the x power, and that's going to be equal to $75,000. Now, I'm going to divide both sides of the equation by $50,000. So if I divide both sides of the equation by $50,000, that would leave me with 1.04 to the x power, and I just know this math off the top of my head. That could be reduced to 3 over 2 or 1.5. I like a decimal. So if I have 1.04 to the x power is equal to 1.5, what I'm going to do is I'm going to apply log to both sides of the equation. because I want that exponent to fall. So now that I've got log of 1.04 to the x power is equal to the log of 1.5, that exponent is going to fly to the front, leaving me with x log of 1.04 is equal to the log of 1.5. Now, I'm going to solve for x by dividing both sides of the equation by log of 1.04. So that means x is approximately, so I'm going to pull out my calculator. So I'm going to do log of 1.5 divided by log of 1.04. Remember to close the parentheses. And I'm going to get 10.338. Okay, but I'm going to actually answer this with 11 years, and I'll tell you why. So 11 years, because there's no such thing as a fraction of a year when they give you your contract at the end of the year going, okay, well, every, 0.338 of a year. No. You get your contract at the end of the year. This is what you're going to make next year. Because if you do, let's say you do $50,000 times 1.04 to the 10th power, you're going to fall just shy of $75,000. However, if you do 50,000 times 1.04 to the 11th power, you're going to get higher than $75,000. So the answer, so the question is asking, how long until you get at least a $75,000 salary? Well, you'd have to go into year 11. It'd be more, but year 10 would be less than $75,000. Does that make sense? Just show the work and go, okay, well, which one will get me at least $75,000? And by that logic, let's figure out how long until I get $100,000, because I'm curious. If you stick around at the same old job. I'm going to put a little line right there just to separate them. So what you do yet again is you set $50,000 times 1.04 to the x power is equal to 100 grand. So you do the same old song and dance. You divide both sides by 50,000 to get that base to the exponent isolated. Now you've got 1.04 to the x power is equal to 2. Hey, that makes sense because $100,000 is double $50,000. So now I want to solve for x, but x is an exponent. So what do I need to do? I'm going to apply the log on both sides of the equation to make that exponent fly to the front. Power factor rule is super useful. Now, I've got log of 1.04 with the x factored out in front is equal to the log of 2. So now, I'm going to divide both sides of the equation by log of 1.04. And let's see what happens. So now I'm going to get x is approximately, I'm just going to round to the nearest 3 decimal places, but then I'm going to use my common sense in the end. So log of 2 divided by the log of 1.04. It would take me 17.672, blah, 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 blah. But let's be real. Will year 17 or year 18 get me $100,000? Right, 17 wouldn't be enough. I think I would fall just shy. So about 18 years. So let's check this out. $50,000 times 1.04 to the 17th power would get me $97,395.02 as my salary. But if I did $50,000 times 1.04 to the 18th power, that's going to make me go above $100,000. Use your common sense. Okay? Hopefully this was a good lesson for you guys. So if anybody ever asks you, when am I ever going to use a logarithm in my everyday life? Well, it's never too early to start planning for your future. Okay? Stay safe. Hope you guys are staying healthy. Have a good day.